Now, in the next segment, what we will do is, see, till now what we have done is, we have calculated the roots, right, when the equation is given. Now what we will do is, suppose we have to find the quadratic equation when the roots are given. So I'll give the heading as find the quadratic equation when the roots are given, right? Let's see, how do we do that? So first, I'll just give you the theoretical aspect of it. If I say, if alpha, beta are the roots, then the quadratic equation of which alpha, beta are the roots, can be given by two formulas. Okay, one formula is x minus alpha into x minus beta equal to 0. This is one formula, right? And if you open this, you will get the second formula. So first formula is very clear, x minus alpha into x minus beta equal to 0, right? So try and memorize this, directly memorize it. If alpha, beta are the roots, then the quadratic equation is given as x minus alpha into x minus beta equal to 0, right? Now let's open this. What happens? If you open it, it will be x square minus alpha x minus beta x plus alpha beta equal to 0. Now this gives us x square. From these two, take minus x common, so it will be alpha plus beta, and this is already alpha into beta equal to 0. Now this can be written as x square minus alpha plus beta is sum of roots into x plus alpha into beta is product of roots, right, equal to 0. So this is the second formula, right? Just memorize it directly. So if the roots are given, the equation can directly be given as x square minus sum of roots into x plus product of roots equal to 0. So one method is this and the other method is this, right? This is the linear factor method, wherein corresponding to every root there is a linear factor. So for alpha it is x minus alpha, for beta it is x minus beta, and this is the quadratic equation. If you open it, you get this as x square minus sum of roots into x plus product of roots equal to 0. In short, this can also be written as x square minus s stands for sum of roots, into x plus p, that is the product of roots, is equal to 0. So this can be presented like this also. Alright. Now let's take some questions. If I say, if roots are 3 and 10, find quadratic equation, what will you do? Let's see. First, let's take both the methods. From the first method, the equation can be written as x minus 3 into x minus 10 equal to 0. So for 3 we have x minus 3, for 10 it will be x minus 10 equal to 0, right? This is first method. And the second method is x square minus sum of roots. Now what is the sum of roots? 3 plus 10, that is 13x, plus product of roots, that is 3 into 10, that is 30, equal to 0, right? So it is x square minus 13x plus 30 equal to 0. You will get the same answer if you open this, okay? So it is either this one or this one. Alright, now let's take another example, or let me put it this way, I'll give you the roots here, okay, and you find the quadratic equation. Okay, see, as much as possible you can, if you're able to do it directly, it will be great. Let's take another example. If I take minus 3 and 10, then the final answer of the quadratic equation following the second formula will be x square minus, what is the sum of minus 3 and 10? So sum will be 7 plus, what is the product of minus 3 and 10? That is minus 30 equal to 0. So the answer is x square minus 7x minus 30 equal to 0. Right? Similarly, what if we have the roots as 3 and minus 10? What will be the equation in this case? Let's see. It will be x square minus, what is the sum of 3 and minus 10? Now, sum of 3 and minus 10 is minus 7. So inside it is minus 7, right? Look at this. It is x square minus sum of roots. So whatever is the sum of roots, the 3 and minus 10 sum is minus 7 into x plus the product of 3 and minus 10 is minus 30, right? That is equal to 0. So this gives us x square minus minus plus 7x minus 30 equal to 0. Alright. Let's take another one. If I have the roots as minus 3 and minus 10, if these are the roots, then what will be the equation? Quadratic equation. What will it be? Let's see. So it is x square minus. What is the sum of minus 3 and minus 10? The sum of minus 3 and minus 10 is minus 13. Right? So it is minus 13x plus the product of minus 3 and 10. Now product of minus 3 and 10 is 30. Right? This is equal to 0. So we have x square plus 13x plus 30 equal to 0. Right? Let's take one more example. What if the roots are 2 by 3 and 5? Now how will you do it? Now let me do this question in two methods. Right? I'll first take the first method and then the second method. Okay. If I take the first method, how do I write it? I will write it as x minus 2 by 3 into x minus 5. That is equal to 0. So this gives us 3x minus 2 by 3 into x minus 5 equal to 0. So what we could have done is we could have directly taken this expression. So 3 goes to the other side, becomes 0. So it is 3x minus 2 into x minus 5 equal to 0. Open it, it will be 3x square minus 15x minus 2x plus 10 equal to 0. So this gives us 3x square minus 17x plus 10 equal to 0. So this is the answer of this question. This is method 1. Now let's look at the direct method, which is the second method. This is one. If I take the second method, it will be x square minus, sum of roots will be 2 by 3 plus 5 into x plus product of roots will be 2 by 3 into 5. That is equal to 0. So this becomes x square minus, if you add, LCM will be 3. It is 2 plus 3 5s are 15. Alright, x plus 2 into 5 is 10 divided by 3, that is equal to 0. Right? So what we have here is x square minus 17 by 3x plus 10 by 3 equal to 0. Just multiply by 3 to the entire thing. It will give us 3x square minus 17x plus 10 equal to 0. Wow. So the answer, final answer, obviously it has to be the same. Okay. So you can use both the methods. Right. Now let's take a couple of more questions on this. Now let's take up some more questions for practice when the roots are given and we have to find the quadratic equation. Let's take up the first question. In this it says find quadratic equation of which the roots are, alright, the roots are, let's say 3 and minus 1 by 2. Right? Now what do we do here? We have two different methods. We'll apply both of them. First, we apply the method of, let's say, if, the first method, that is, if alpha, beta are the roots, then the equation can be, if alpha, beta are roots, then the equation can be given as x minus alpha into x minus beta equal to 0. Now here there is one small clarification that is required. Let me put it like this. If the roots are minus alpha and minus beta, then what will be the equations? If these are the roots, then the equation will be given as, please look at it carefully. When the root is alpha, the expression is x minus alpha. When the root is beta, expression is x minus beta. When the root is minus alpha, expression will be x plus alpha. When the root is minus beta, expression will be x plus beta, that is equal to 0. Similarly, if one root is positive, let's say alpha, and the other root is negative, let's say minus beta, if these are the roots, then the expression will be given as, look at this carefully, for alpha it will become x minus alpha, and for minus beta it will become x plus beta. So these things can be used directly, right? So if I use the first method, in that case, the answer for this question, the required equation will be given as, straight away x minus 3, because the root is plus 3, and the other root is minus 1 by 2, so we'll take x plus 1 by 2, that is equal to 0, right? And then you simplify it. So first part is x minus 3, second part will become 2x plus 1 whole divided by 2 by taking LCM, right? So 2 goes to the other side and becomes 0. This side we will have x minus 3 into 2x plus 1 equal to 0. If you open the bracket, if you simplify, it will give us x multiplied by 2x, it is 2x square, plus x into 1 is plus x, minus 3 into 2x is minus 6x, minus 3 into 1 is minus 3, that is equal to 0. So this means our answer will be 2x square minus 5x
minus 3 equal to 0, right? So this is the answer of this question. Okay, so this was method 1, right? Don't forget it is method 1. Now there is another method to do the same question. Let's see. So now we'll do the method 2 of the same question. The roots are 3 and minus 1 by 2. Now method 2 is related to the sum and the product of roots. That's very simple, right? So first we find the sum of roots. The sum of roots in this case is 3 plus minus 1 by 2, which is eventually 3 minus 1 by 2. That is LCM 2 in denominator. In numerator we'll have 3 into 2, that is 6 minus 1, which is 5 by 2. And the product of roots will be given as 3 into minus 1 by 2, which is simply minus 3 by 2. Right? So sum of roots is 5 by 2, product of roots is minus 3 by 2. So the required equation can be given as x square minus the sum of roots into x plus the product of roots equal to 0. So it is x square minus sum of roots is 5 by 2 into x plus product of roots is minus 3 by 2 equal to 0. So if you open it, it will be x square minus 5x by 2 minus 3 by 2 equal to 0. Just multiply by 2 in every term, we will get 2x square minus 5x minus 3 equal to 0. Right? So this is the answer of this question. As you can see, it is the same as it was earlier. Right? So the answer here was 2x square minus 5x minus 3. Here also it is 2x square minus 5x minus 3 equal to 0. Alright. Now let's go to the next question of the same type. Alright, now this question says find quadratic equation of which the roots are minus 8 and 7 by 5, right? So we have already shown the methods in detail. Now I'll do in short. Let's say method 1. From method 1, I can directly say the equation will be x plus 8 into x minus 7 by 5 equal to 0, right? So if I simplify it, it is x plus 8 into 5x minus 7 whole divided by 5 equal to 0. Now this 5 goes to the other side, so it becomes 0. Now x plus 8 into 5x minus 7, if you open it, if you multiply, x into 5x is 5x square, x into minus 7 is minus 7x, plus 8 into 5x is 40x, minus 56. 8 into 7 is 56 equal to 0. So the final answer is 5x square plus 33x minus 56 equal to 0. Right? So this was one very beautiful situation. Obviously method 1 is going to be slightly faster in some cases, and at the same time method 2 is also going to be faster in some cases. So here method 1 looks a little faster. Let's take method 2. Alright, the method 2 demands that you find the sum of roots and the product of roots separately. So here it is minus 8 and 7 by 5. Now the sum of roots will be equal to minus 8 plus 7 by 5. So LCM in denominator will be 5 and numerator will be minus 8 into 5 is minus 40 plus 7. So it is equal to minus 33 divided by 5. Okay. And then we have the product of roots. And our product will be a simple multiplication of these two numbers. That is minus 8 into 7 by 5, which is straight away minus 56 upon 5. Alright. So the answer will be x square minus the sum of roots is minus 33 by 5. Put it there into x plus the product of roots, that is minus 56 upon 5, that is equal to 0, right? So if you just multiply by 5 and adjust the sign, it will become 5x square plus 33x minus 56 equal to 0. So it depends a little bit of practice also, right? And you can see the answer is same in both the cases. Whichever you like, you can apply. Whichever method you like, you can apply. Nothing to worry about. All right. Now let's take one more question on this. Now this question says find quadratic equation of which the roots are 3 by 4 and 5 by 8. I'll still go ahead and do method 1 first, right? Now method 1 says that for 3 by 4, our expression will be x minus 3 by 4. Okay. And for 5 by 8, expression will be x minus 5 by 8 equal to 0. Now here I'll show you one thing. You can take 4x minus 3 as one part. The 4 in denominator goes to the other side, and the second expression will become 8x minus 5. 8 in the denominator goes to the other side, right? Here, this statement you could have directly written, right? So if you have a little bit of practice, you don't need to write this part. You can directly start from here. Okay, but in any case, let's multiply and open. 4x into 8x is 32x square Minus 4x into 5 is 20x. Minus 3 into 8x is 24x. Minus 3 into minus 5 is plus 15. That is equal to 0. So we have 32x square minus 44x plus 15 equal to 0 as the answer of this question. Alright. Now let's take method 2 of this. For method 2, we need to find the sum and the product of roots. The roots are 3 by 4 and 5 by 8. So let's first find the sum. The sum of these roots will be 3 by 4 plus 5 by 8. LCM of 4 and 8 is 8. So 4 2s is 8. So 3 2s is 6 plus 5, right? So it is 11 by 8. That is the sum of roots. Similarly, product of roots. Now let's see, the product of roots will be a simple multiplication of 3 by 4 and 5 by 8. Now this is 3 into 5 is 15. 8 into 4 is 32. Right? So our required equation will become x square minus the sum of roots is 11 by 8 into x plus the product of root is 15 by 32. Right? That is equal to 0. Now here if you multiply the whole thing by 32, what will happen? We will get 32x square minus 32 into 11x by 8 plus 32 into 15 by 32. Right? So what we are doing is we are multiplying every term by 32. Now the last one, 32 cancels by 32. 8 cancels 32 4 times. So our final answer in this case is equal to 32x square minus 4 into 11x is 44x plus 15 is equal to 0. So as you can see, the answer is same. In any case, answer will come same only, right? So here I just wanted to show all the methods. That is why I've done every question in 2 different ways, right? In exam, you will be required to solve or use only one of them, only one of the methods. All right. Now let's go to the next part.
All right. Now we will also try to deal with the situations of irrational roots and imaginary roots. Right? If you remember, both irrational roots and imaginary roots, irrational or imaginary, both of them were in pairs. Right? They were always in conjugate pairs. Okay? How do we use this information in questions? Let's see. I'll give you the question like this. Now, let's take up this question. It says if 2 root 3 plus 7 is one root of a quadratic equation, find that quadratic equation, right? How do we go about it, right? The formula that we have is either x minus alpha into x minus beta equal to 0. So we need both alpha and beta. Or it is x square minus sum of roots into x plus product of roots, right? For that also, to find the sum we need both the roots, and to find the product also we need both the roots. Right? In this case, there is only one root given. Nothing to worry. Right? How? See, the irrational and the imaginary roots are always in pairs, always in conjugate pairs. So if I have one root as 2 root 3 plus 7, so let's say it is alpha, right? Then we automatically know beta, it will be equal to the conjugate of this, right? And remember, how do you decide conjugate? We have discussed it earlier. The conjugate means change the sign of the problematic part. And what is the problematic part? The problematic part is the irrational part, okay, or the imaginary part. So when you have to change the sign, please understand that to take conjugate pair, you have to change the sign of either the irrational part or the imaginary part. Here it is a case of irrational number. So if one root is 2 root 3 plus 7, the other root will be minus 2 root 3 plus 7, right? This is the point where a lot of people would make mistake. Remember, when I say a plus b, the conjugate of this will be a minus b, right? But condition is b has to be the irrational part. Then only we can do this. If a is the irrational part, so for example, if it is a plus root b, then the conjugate will be a minus root b, right? But if it is root a plus b, then the conjugate will be minus root a plus b, right? Be really careful about here, right? This is very important. You have to change the sign of the irrational part. Okay, so come back to this. So now we have our 2 roots. Now if you add, the sum of roots will be equal to the sum of these two. Simply add 2 root 3 and minus 2 root 3 gets cancelled, and we will have 7 plus 7, that is 14. Right? And similarly, you can calculate the product of roots. Product of roots will be equal to, we can see the roots are 2 root 3 plus 7 into minus 2 root 3 plus 7. Now this is actually 7 plus 2 root 3 into 7 minus 2 root 3. Okay, so it is a plus b into a minus b, and it becomes 7 square minus 2 root 3 square. Now 7 square is 49 minus 2 root 3 square is 4 into 3, that is 12. So 49 minus 12 is 37. So now we have the sum of roots and the product of roots. So from the second method, we can directly find that the required quadratic equation is x square minus the sum of roots into x plus the product of roots equal to 0. Here we can say it is x square minus, in place of sum of roots we can place 14 into x plus, in place of product of roots we can place 37, right, equal to 0. So the final answer is x square minus 14x plus 37 equal to 0, right? This is the answer of this question. Alright, so just be careful if the roots are irrational or imaginary. Only one root is sufficient to be given, because the other root has to be taken as the conjugate pair. Alright, so if one root is given 2 root 3 plus 7, then the other root will be the conjugate of this, that is minus 2 root 3 plus 7. So if you add them, you will get 14. If you multiply them, you will get 2 root 3 plus 7 into minus 2 root 3 plus 7, which is 7 plus 2 root 3 into 7 minus 2 root 3, which is 7 square minus 2 root 3 square. 7 square is 49. 2 root 3 square will be 4 into 3, that is 12. 49 minus 12 is 37. The answer of this question will be x square minus 14x plus 37, that is equal to 0. Alright, let's just take one more question. Now, in this question, it says 4i plus 5. Now, remember, I is the imaginary number, right? So, it says 4i plus 5 is one root of the quadratic equation. Find that quadratic equation. So, here one root is given 4i plus 5. Let's say it is alpha. Then the other root will be the conjugate of this. And the conjugate will be the number formed by changing the sign of the imaginary part. So, it will become minus 4i plus 5, right? So, we have, if you add them, the sum will be 4i and minus 4i will get cancelled. 5 plus 5 will be 10, right? That is the sum of roots. Similarly, the product of roots, if you see, it will be the multiplication of these two items, and that is equal to 4i plus 5 into minus 4i plus 5. Okay, so this gives us 5 plus 4i into 5 minus 4i. So it is 5 square minus 4i whole square. Now 5 square is 25 minus 4i square is 16i square. Now we know that I is equal to root of minus 1 and I square is equal to minus 1. Okay, so it is 25 minus 16 into minus 1, which is 25 plus 16, that is 41. So the sum is 10, product is 41. So the equation, required equation, is given as x square minus the sum of root into x plus the product of roots equal to 0. So it is x square minus the sum of roots is 10, so 10x, plus the product of roots is 41, so plus 41 equal to 0. Right? This is the required answer. Okay, now let's take a couple of more questions and then we'll go to the next part.
Now let's take some more questions on this concept. Here is the first question. It says, find quadratic equation of which one root is 3 root 3 minus 5. So let's say one root is alpha, that is 3 root 3 minus 5, right? That means the other root, beta, we know that it is an irrational root. Now irrational roots are always in conjugate pairs. So irrational conjugate, right? So if I have one root as 3 root 3 minus 5, then the other root will be, we can get it by changing the sign of irrational part. So it becomes minus 3 root 3 minus 5, right? So from here, if you add, you will get the sum of roots, that is alpha plus beta, which will be equal to 3 root 3 and minus 3 root 3 get cancelled. Minus 5 is minus 10, right? So this is our sum of roots. Similarly, if you multiply, you will get the product. Now product of alpha into beta, that will be equal to, write it properly, it is 3 root 3 minus 5 into minus 3 root 3 minus 5. Let's do one thing. Take minus common from this and as well as this. So 2 minus come out and it will become positive. So we get 5 minus 3 root 3 and the other side will become 5 plus 3 root 3. So if you multiply, it becomes 5 square minus 3 root 3 square. Now 5 square is 25 minus 3 root 3 square will be, 3 square is 9 and then root 3 square is 3, that is 27. So it is minus 2, right? So the sum of roots is minus 10 and the product of roots is minus 2, right? So that means our required equation will be x square minus sum of roots into x plus product of roots, that is equal to 0. So here it is x square minus, in place of sum we will put minus 10, all right, into x, plus in place of product we will put minus 2, that is equal to 0. So our answer will be x square plus 10x minus 2 is equal to 0, right? So this was one good question. Now let's take up the next question. It says find quadratic equation of which one root is 6 minus 2 root 5, right? So let's say alpha, that is one root, is 6 minus 2 root 5. Again, this is an irrational number. So the other root beta can be taken as change the sign of irrational part. Irrational part is 2 root 5. So it becomes, here it is already minus, so we'll take plus 2 root 5, right? So if I add, we will get the sum of roots, that is alpha plus beta, and that will be equal to 2 root 5 cancel, 6 plus 6 is 12. So this is the sum of roots. Similarly, if you multiply, you will get the product of roots. Now product of roots will be alpha into beta. Alpha into beta is 6 minus 2 root 5 into 6 plus 2 root 5. Now this is a minus b into a plus b, it will become a square minus b square. So it becomes 6 square minus 2 root 5 whole square. 6 square is 36. 2 root 5 square will be, 2 square is 4, root 5 is 5. So 4 into 5 is 20. 36 minus 20 is 16. So this is the product of roots. So we have our sum of roots as 12 and product of roots as 16. That means the answer can be given as x square minus the sum of roots is 12 into x plus the product of roots is 16. That is equal to 0. So straight away it is x square minus 12x plus 16 equal to 0. Right? So this is the answer of this question. Okay, now let's take up the next question, which is based on imaginary roots. All right. Now let's take up this question. It says find quadratic equation of which one root is 7i minus 3. Now these are 7i minus 3 is an imaginary root, right? So that means now we know that imaginary roots are also conjugate. Okay, and how do we find conjugate? Just change the sign of the imaginary part. Here, if I take one root as 7i minus 3, the other root, let's say beta, will be equal to, we have to change the sign of imaginary part. So 7i is the imaginary part, so it becomes minus 7i. And the other part remains as it is, so minus 3. So now if you add, you will get the sum of roots, that is alpha plus beta, equal to 7i and minus 7i will get cancelled. Minus 3 will become minus 6. So this is our sum of roots. Right? Similarly, if you multiply, the product of roots you will get as alpha into beta, which is equal to, in place of alpha it is 7i minus 3, in place of beta it is minus 7i minus 3, right? So take out minus common from both these two things. From first one, if you take out minus common, it will become 3 minus 7i, and from the second one, if you take out minus common, it will be 3 plus 7i, and 2 minus outside will become positive only. Right? So it is just 3 minus 7i into 3 plus 7i, which will be equal to, now this is a minus b into a plus b. So it is a square, that is 3 square, minus b square, that is 7i square. Now 3 square is 9 minus 7 square is 49 and I square. Now we must know that I is equal to square root of minus 1. That means I square is equal to minus 1. So 49i square will become, it will become 9 minus 49 into minus 1. So it becomes 9 plus 49. Now 9 plus 49 is 58. So this is our product of roots. So we have our sum of roots as minus 6, product of roots as 58. That means the required equation will be given as, I'll write here, the required equation will be given as x square minus sum of root into x plus product of roots equal to 0. Here we have, it is x square minus sum of roots is minus 6 into x plus product of roots is 58. So plus 58, that is equal to 0. Right? So this means it is x square minus minus 6. So it is x square plus 6x plus 58 equal to 0. So this is the answer of this question. Okay. Let's take one more question like this. Now let's take one more question in this. It says find quadratic equation of which one root is minus 2i minus 3. So let's say the one root is alpha, that is minus 2i minus 3. Now this is imaginary root, so the other root beta has to be the conjugate pair of this, and in that we just change the sign of imaginary part. So here it is minus 2i, so in the second root it will be plus 2i minus 3. Right? Now if I add these two, so the sum of roots will be equal to alpha plus beta, which is equal to this 2i and 2i will get cancelled. We'll have minus 3 minus 3, that is minus 6. So sum of the roots is minus 6. Then the product of roots we can calculate by multiplying the roots. Here it is alpha into beta. Alpha is equal to minus 2i minus 3 multiplied by 2i minus 3. So what we can do is we can take out minus common from both these two items. So the first one will become 2i plus 3 and the second one will become 3 minus 2i. Now because we have taken minus common from both, there will be no change in the final answer, in the final sign. So it is still positive. Now this is equal to 3 plus 2i into 3 minus 2i. Right? So we can say it is 3 square, it was a plus b into a minus b, so a square minus b square. So 3 square minus 2i square. Now 3 square is 9, right? Minus 2i square is 4i square. We know that I square is minus 1, so it is 9 minus 4 into minus 1. So it becomes 9 plus 4, which is 13. This is the product of roots. So we have sum of the roots as minus 6, product of roots as 13. Alright, so the required equation can be given as, right, so I'll say the required equation is directly x square minus the sum of roots into x plus the product of roots equal to 0, which is x square minus, in place of sum we'll say it is minus 6x plus in place of product it is 13, right, that is equal to 0. So the answer of the question is x square plus 6x plus 13 equal to 0. Alright, so this is the answer of this question. Okay, now let's go to the next topic.
Now the next topic that we have is transformation of roots. Right, now what does it mean? Let's see, I'll give you the question, you will be able to make out. Transformation of roots. Let's take up a question. We say that if alpha, beta are the roots of 5x square minus 8x minus 3 equal to 0, find the quadratic equation of which the roots are 2 alpha and 2 beta. Now how do we go about this? This is a very simple question. Okay, let's look at this. It says alpha, beta are the roots of 5x square minus 8x, 5x square minus 8x minus 3 equal to 0. Now if alpha, beta are the roots of this, that means from here we can find sum of roots and product of roots. Now what is sum of roots? We know that sum of roots formula is minus b by a. So from ax square plus bx plus c, we know that alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. So from here we can see that a is equal to 5, b is equal to minus 8, c is equal to minus 3. So sum of roots, that is alpha plus beta, will be equal to minus b by a, that is 8 by 5, right? And the product of roots alpha into beta will be c by a, that is minus 3 by 5, right? So this is the sum of root and this is the product of root. Now how does it help in our question here, right? Now I'll just draw a line here and then we'll say for our new equation that we have to calculate, new required equation, right? The roots are 2 alpha and 2 beta. So for the new equation, okay, the sum of roots will be equal to 2 alpha plus 2 beta. If you take out 2 common, it will be 2 into alpha plus beta, and alpha plus beta we already have, that is 8 by 5. So this becomes 2 into 8 by 5, which is 16 by 5, right? Similarly, for the new equation, the product of roots See, the new equation has the roots as 2 alpha and 2 beta, right? So the product of these roots will be equal to 2 alpha into 2 beta, and that will be 2 into 2, 4 alpha beta. Now we already have alpha beta as minus 3 by 5, so it is 4 into minus 3 by 5, which is equal to minus 12 by 5. Alright, so this is the second part. So we have the sum of roots, that is S, and the product of roots, that is P. So this means our new equation can be directly given as x square minus sum of roots into x plus product of roots equal to 0. Just put it there. So it is x square minus sum of roots is 16 by 5 into x plus product of roots is minus 12 by 5 equal to 0. So multiply by 5, it will become 5x square minus 16x minus 12 equal to 0. Right? So this is the answer of question. Right? But here you can see that this is a really long process. Do we really need to do that? No, we don't need to. So I'll give you a shortcut method for this. Right? The shortcut method would be, look at this carefully. We can do this here only. See, I'll write it like this. Alpha, beta are the roots of the equation given 5x square minus 8x minus 3 equal to 0. We have to find the equation of which the roots are 2 alpha and 2 beta. Okay. Now what are the steps that we need to do? See, first of all, just check what is the change in the root that has happened. What is the transformation in the root that has happened? Here it is just multiplied by 2. So alpha becomes 2 alpha. In place of beta, we get 2 beta. So basically the roots are being multiplied by 2. Right? So the new equation will be, first of all, the new equation will have the same structure as it was earlier. See, understand one thing, that alpha and beta are both going through the same change. So alpha is being multiplied by 2, beta is being multiplied by 2. Whether it is being multiplied or divided, that doesn't matter. What matters is the change in alpha should be same as the change in beta. If that is happening, then the new equation structure will be exactly same as the previous equation. It is just that in place of x, we will take something else. Right? So I'll first write the structure of the new equation. The new equation will be 5 into something square minus 8 into something minus 3 equal to 0. This will be the new equation. Right? So the structure is the same. But what about these places? What do we get here? Earlier here it was x. Now, we have multiplied the roots by 2. So in x, divide by 2. So here it will be x by 2. Remember, if you change the roots, you have to change x also by the reverse change. So if the roots are being multiplied by 2, x will be divided by 2, and just simplify that. So it will give us 5x square by 4 minus 2 cancels 8 4 times 4x minus 3 equal to 0. Multiply by 4, it will give us 5x square minus 16x minus 12 equal to 0. I think you can see that this is the same answer. Alright. So what did you have to do? If the changes done in alpha and beta are the same, then in that case, you can directly find the equation. If you have the equation given for alpha beta as something, then for 2 alpha 2 beta, the same structure of equation, just in place of x, write x by 2. Right? Let's take another example. Now let's take this one. What does it say? It says alpha beta are the roots of this equation, that is 5x square minus 8x minus 3 equal to 0. We have to find that equation of which the roots are alpha by 3, beta by 3. First thing, check whether the change in alpha and change in beta is same. Yes, it is same. It is division of 3. So here our new equation will be of same structure as the original equation, that is 5 into something square minus 8 into something minus 3 equal to 0. But because the roots are being divided by 3, x will get multiplied by 3. So in place of x, we will have 3x. In place of x, we will have 3x. And just simplify that. So 3 3s are 9. So 5 into 9x square minus 24x minus 3 equal to 0. Right? So if you divide by 3, it will be 5 9 is 45. First, let me write it. 45x square minus 24x minus 3 equal to 0. Now divide by 3, it will give us 15x square minus 8x minus 1 equal to 0. Right? So this becomes really simple. Okay. Let's take one more example. If I say that alpha beta are the roots of 5x square minus 8x minus 3 equal to 0, then find the equation of which the roots are alpha plus 2 and beta plus 2. Right? So I'm saying alpha beta are the roots of this equation. Then what will be the equation of which the roots are alpha plus 2 and beta plus 2? Now what do you do? The new equation will have the same structure. So it is 5 into something square minus 8 into something minus 3 equal to 0. So the structure is the same. It is just that in place of x, what do we write here? We have to decide. Now what are we doing? Here we are saying that the roots are added by 2. So plus 2. That means in x we will subtract by 2. So x minus 2 comes here, x minus 2 comes here. See, we are adding 2 to the roots. So x will get subtracted by 2. Right? Simplify this. So it is 5 into x square minus 4x plus 4 minus 8x plus 16 minus 3 equal to 0. Just be a little careful about the sign. So if you open it, it will be 5x square minus 20x minus 8x. So minus 28x. 5 into 4 is 20 plus 16 is 36 minus 3 is 33. So this is equal to 0. This is the answer of this question. Alright. Okay, let's take one more example. Suppose we say that if alpha beta are the roots of this equation, then what will be the equation of which the roots are, let's say, minus alpha and minus beta? What do you do? So here what we are doing is we are multiplying by minus 1. Okay. So what we'll do here, we'll take x divided by minus 1. Eventually it will come out to be the same. Okay. So it will be x divided by minus 1 minus 3 equal to 0. So this becomes 5x square minus plus ac minus x whole square will be x only, x square only, and this becomes plus 8x minus 3 equal to 0. So this will be the answer. Suppose we have a question like this which says if alpha beta are the roots of 5x square minus 8x minus 3 equal to 0, right? Then what will be the equation for which the roots are 1 by alpha and 1 by beta? So what are we doing here? We are inverting. So here also we'll invert. Okay, so inverting is negated by invert only. 1 by x becomes equal to x. So if the roots are getting inverted, the x will also get inverted. So it becomes 5 into 1 by x whole square minus 8 into 1 by x minus 3 equal to 0. So this gives us 5 divided by x square minus 8 by x minus 3 equal to 0. So this gives us 5 minus 8x. If you multiply by x square in the whole thing, minus 3x square equal to 0. This is 3x square plus 8x minus 5 equal to 0. You can also see that when the roots are inverted, the expression just rotates horizontally, right? Like this. So this is 3x square plus 8x minus 5, that is equal to 0. Okay, so there can be several other situations like this. Let's take one more of this. Suppose we say that alpha beta are the roots of 5x square minus 8x minus 3 equal to 0. Then what will be the equation of which the roots are alpha minus 1 and beta minus 1? What will happen? So here both alpha and beta are getting subtracted by 1. So in the answer it will be 5 into x plus 1 whole square minus 8 into x plus 1 minus 3 equal to 0. You just have to memorize that whatever change happens in alpha, the reverse change of that must happen in x. So if you open it, it will be 5 into x square plus 2x plus 1 minus 8x minus 8 minus 3 equal to 0. So final answer will be 5x square plus 5 to 2 is 10x minus 8x 2x, 5 minus 8 minus 3. So 8 and 3 11, 5 minus 11 is minus 6 equal to 0. So this will be the answer in this case. Alright, so I think we have sufficient number of examples that we have done here. Okay, now let's go to the next part. Now we come to a very important part, that is remainder theorem and factor theorem. So first we will take remainder theorem. Right? Let's take up an example and try to understand from here. Divide 5x square minus 3x plus 7 by x minus 2 and find remainder. Right? So we have to divide something by something and we have to find remainder. Now, if you recall remainder, let's say for example divide 56 by 9. Just to show, I can write 56 here, 9 here, 9 6 is 54, minus subtract, you get 2 here. So we say this 2 is the remainder, right? This is what we have done in numbers, right? Now the same thing can be implied in algebra also. Okay, how do we do that? Let's see. So here one method is we write 5x square minus 3x plus 7, okay, and we divide it by x minus 2. So one by one, here the way we did the maximum multiple, here we look at the maximum degree. Here the maximum degree is x raised to 1, here it is x square, so multiply by x. But only multiplication of x will give us x square, so that will not help. So multiply by 5x. So instead of x, take 5x here. Now 5x multiply to this whole thing will give us 5x square minus 10x, and then subtract. So this becomes minus, this becomes plus. 5x square gets cancelled. Minus 3x plus 10x is 7x plus 7. Alright. Now here we have 7x, here we have x. So multiply by 7. So let's take plus 7. So if you multiply by 7, it will be 7x minus 14, and then subtract. So the 7x becomes negative, minus 14 becomes positive. So 7x cancelled, we have 7 plus 14, that is 21. So this 21 is the required remainder, right? So this is the answer of this question. Now, please understand that this method is definitely going to take a longer duration, longer time, right? We don't need this. We have a simpler method also. How? Let's see. Come back here and then see that this 56 can also be written as 54 plus 2. And this 54 is actually 9 into 6 plus 2. So actually the rule was that the number is equal to the divisor into the quotient plus remainder. Alright. That rule is applicable even in algebra. Okay. So as I said, we don't need to follow this method because this is going to be really tedious. So I'll remove this. Then what should we do? Let's see. We are saying that whenever any number is divided by a divisor, there is some quotient and there is some remainder. Here, this thing is the number, this thing is the divisor, and r we have to find, that is the remainder. I'll write n here, that is 5x square minus 3x plus 7 is equal to, divisor is x minus 2 into some quotient plus remainder. Now we have to find r, right? That means we don't need this. Now, mathematically, how do I remove this? Right? It's very simple. We don't know about q, but we know about x minus 2. So if I put x minus 2 equal to 0, I'll get my required remainder. Now to put x minus 2 equal to 0, what do we need to do? We need to put x equal to 2. To find the required remainder, put x equal to 2 in this entire expression. So if I put x equal to 2, what will happen? It will be 5 into 2 square minus 3 into 2 plus 7, that is equal to 0 into q plus r. So automatically you will get the required remainder here, because 0 into q is 0. And this side will be 4 into 5, that is 20, minus 3 into 2 is 6 plus 7. So the required remainder is 20 plus 7, 27 minus 6 is 21. Right? So we are going to get the same answer. Okay? I'll further reduce it. You don't even need to write any one of these things. Okay? So I'm going to remove this completely. I'm going to remove this completely, and just understand that whenever, look at the condition, whenever the the condition is divisor should be of degree 1. Divisor should be of degree 1. Just remember that. Only in that case, you can use a very simple rule. Whenever this happens, when the divisor is of degree 1, simply equate the divisor to 0. You get a value of x from there. Whatever value of x you get from here, put it in this expression, that will be the required remainder. I repeat, if the divisor is degree 1, in that case, simply equate the divisor to 0, find some value of x, put this value of x in the given expression, you will get your required remainder. So the required remainder will be x equal to 2, you have to put here in place of x. So it is 5 into 2 square minus 3 into 2 plus 7, that is equal to 4 into 5 is 20 minus 6 plus 7, that is 21. So straight away we can get such situations. Alright. So this is a very beautiful question. Remember, the dividend can be any polynomial. Dividend can be any polynomial. Okay. But the condition is the divisor has to be degree 1 only. Okay. Let's take another example. If I say divide 3x square or 3x cube plus 7x square minus 4x minus 9 by x plus 2. Find remainder. Alright, now what do you need to do in this? The dividend can be of any degree, doesn't matter. Okay, just equate the divisor to 0. So x plus 2 is 0, that means x equal to minus 2. Straight away put x equal to minus 2 in this whole expression in place of x, you will get your remainder. So the required remainder is equal to 3 into minus 2 cube plus 7 into minus 2 square minus 4 into minus 2 minus 9. Right? Now if you simplify, now the calculation has to be done properly. So it is 3 into minus 8 plus 7 into 4 plus it will be minus into minus plus, so 4 into 2 minus 9. So simplify this, it is minus 24 plus 28 plus 8 minus 9. Right? So this gives us 28 minus 24 is 4, 8 minus 9 is minus 1, so it is 3. So the final answer of the question in this case is 3. Right? So this was a very, very good situation. Let's take a couple of more questions. Now that we have done remainder theorem, from here only we can get factor theorem. Right? Let's see how. If I take an expression, divide x square minus 5x plus 6 by x minus 2. Let's do that. Find remainder. Okay. I'm taking a very simple example. I'm sure a lot of you are already aware about it. So find the remainder. Now to find remainder, what do we need to do? We need to take x minus 2 equal to 0. That gives us x equal to 2. Right? Now if I put x equal to 2 here, I'll get required remainder as 2 square minus 5 into 2 plus 6. Now 2 square is 4, minus 5 into 2 is 10 plus 6. Now 4 plus 6 is 10, 10 minus 10 is 0. Oh, so if my remainder is 0, we say that this item is divisible by this. See, whenever remainder comes 0, if I, let's say for example 54, if I divide by 9, 9 6 is 54. So cancel 0. So remainder 0 means 9 divides 54, 6 divides 54 completely. Or we can also say that 54 is divisible by 9 and 6. We can also say that 9 and 6 are factors of 54. You know, remember that n is equal to d into q plus r. If r becomes 0, then what will happen? N will be equal to d into q. That means in that case, n is divisible by d and q both. In that case, we can say that both d and q are factors of n. So here also, if the remainder is 0, that means this x square minus 5x plus 6 is divisible by x minus 2. So here we can, when remainder is 0, we can say that the dividend is divisible by this, or this divisor, the divisor is a factor of the given dividend. Alright, so divisor is this one and this is the dividend. Okay, right? So this is the factor theorem. So what does factor theorem say? If the remainder is 0, that means this x minus 2 or this divisor is a factor of this given expression. Okay, let's take a couple of questions on them. Now look at this question very carefully. It says if x plus 3 is a factor of 2ax square minus 5x plus 6, find a. Right? Now if x plus 3 is a factor, that means the remainder should be equal to 0. Which remainder? When this expression is divided by x plus 3, remainder should be 0 because it is a factor. Okay. Now to find remainder, what do? We take the divisor equal to 0. So we get some value of x from here, that is x equal to minus 3. We put x equal to minus 3 in this to find remainder. Now if I put x equal to minus 3 in this, what will happen? We will get 2a into minus 3 square minus 5 into minus 3 plus 6. Alright. Now please understand that this is the required remainder and this has to be equal to 0 because x plus 3 is a factor. Now simplify this. Now minus 3 square is 9. So 2a into 9 is 18a plus, because minus into minus is plus, 5 into 3 is 15 plus 6, that is equal to 0. So we have 18a equal to minus 21. 15 plus 6 is 21, goes to the other side, becomes minus 21. So A is equal to minus 21 upon 18. If you divide by 3, it is A equal to minus 7 by 6. So this is the answer of this question. So this is how the questions on factor theorem can be asked. Okay.
Now let's take up a couple of more questions on finding remainder. Right? Let's look at this question. It says, divide this expression 4x cubed minus 6x squared plus 3x minus 9 by x minus 3 and find remainder. The only condition that we need to check the divisor, whether the divisor is of 1 degree or not. As you can see, this is a 1 degree expression. X minus 3 is 1 degree. Dividend can be of any degree. The thing which is going to be divided can be of any degree. But the divisor has to be 1 degree. Here the divisor is x minus 3. That is 1 degree. We simply take the divisor equal to 0. From here we get the value of x equal to 3. So we put x equal to 3 in the given expression. Right? Now the given expression is this one. Okay, just put x equal to 3 in this. Your required remainder you will be able to calculate. So required remainder is equal to 4x cube, that means it is 3 cube, minus 6x square, it is 6 into 3 square, plus 3 into 3 minus 9. Now just simplify this. It is 4 into 3 cube is 27, minus 6 into 3 square is 9, plus 3 into 3 is 9, minus 9. Now 9 and 9 are cancelled. 4 into 27 is 108. 6 into 9 is 54. Alright, so 108 minus 54 is 54. So the final answer of this question is 54. A simple direct question of division and finding the remainder. Alright. Now let's take up this question. It says divide 7x squared plus 8x minus 13 by x plus 2, find remainder. Our condition, divisor has to be 1 degree. X plus 2 is 1 degree. Simply equate x plus 2, the divisor, to be 0. From here we get x equal to minus 2. Put x equal to minus 2 in this expression. The required remainder will straight away be equal to 7x square plus 8x minus 13. In that, put x equal to minus 2. So it is 7 into minus 2 square plus 8 into minus 2 minus 13. Right? So it is 7 into minus 2 square is plus 4. So 7 into 4. 8 into minus 2 is minus 16 minus 13. So we have 7 fours are, that is 28, minus 16 and 13 is 29. So 28 minus 29, that is equal to minus 1. So the answer of this question is simply minus 1. That means when this expression is divided by x plus 2, the remainder is minus 1. Okay. Now let's take this question. It says divide 6x square minus 5x plus 9 by 2x minus 3. Simply equate 2x minus 3 to 0. We get x equal to 3 by 2. Put x equal to 3 by 2 in this expression. This will give us the remainder. So the required remainder is straight away equal to 6 into x square. That means 3 by 2 square. We have to substitute 3 by 2 in place of x. Right? So it is 6 into 3 by 2 square minus 5 into 3 by 2 plus 9. Right? Simplify this. It is 6 into 3 by 2 is 9 by 4. 3 by 2 square is 9 by 4. Minus 5 into 3, that is 15 by 2 plus 9. Alright. Now 2 cancels 4 2 times and 6 3 times. So this gives us 27 by 2 minus 15 by 2 plus 9. Now 27 minus 15 will become 12 by 2. So it is 12 by 2 plus 9. Now 12 by 2 is 6 plus 9, that is equal to 15. Right? So the answer of this question is 15. But in any case, you can see that the divisor has to be equated to 0. We get some value of x and put it in the expression to find the remainder. Alright. Now let's take a couple of tricky questions here. Now this question says if x minus 2 is a factor of 3x square minus 5px plus 6, then find p. Now here what it means is when I say x minus 2 is a factor, that means when this expression is divided by x minus 2, remainder should be equal to 0. Right? Remainder should be equal to 0. Why? Because x minus 2 is a factor. Okay, so when it is divided by x minus 2, remainder should be 0. Now, how do we divide? How do we find remainder? To do that, we still follow the same process. X minus 2 equal to 0. We put divisor equal to 0. We get some value of x, that is x equal to 2 in this case. Put it in this expression, that will be the remainder. So the required remainder in this case should be 3x square minus 5px plus 6. In that, put x equal to 2. So it will give us 3 into 2 square minus 5p into 2 plus 6. And this remainder should be equal to 0. So if you simplify, 2 square is 4, 4 into 3 is 12, minus 5 into 2 is 10p, plus 6, that is equal to 0. Now 12 plus 6 is 18, minus 10p goes to the other side and becomes 10p. So 18 is equal to 10p, or if you cancel by 2, it is 9 equal to 5p. So from here, we can see that p value is equal to 9 divided by 5, right? Or 1.8. Depending upon the option, you can mark the answer. So here the value of p as asked in the question is 9 by 5 or 1.8. Alright, let's take one more good question. Now look at this question very carefully. It says if x plus 2 and x minus 1 are factors of this expression 4ax cube minus 7x square plus 8x plus 3b, find the values of a and b. Right, now let's do one thing. So one thing is very clear, that x plus 2 is a factor, x minus 1 is a factor. That means when we divide this given expression by x plus 2, remainder should be 0. Similarly, when we divide this given expression by x minus 1, then also the remainder should be 0. Okay, so let's do one thing. Let's go one by one. Let's first do it for x plus 2. For x plus 2, to find the remainder, what we need to do is take x plus 2 equal to 0. So this will give us x equal to minus 2. Put x equal to minus 2 in the given expression. So the required remainder will be equal to 4a into minus 2 cube minus 7 into minus 2 square plus 8 into minus 2 plus 3b, and the remainder should be equal to 0 because x minus 2 is a factor. So 0 is equal to, if you simplify, minus 2 cube is minus 8, minus 8 into 4 is minus 32. So it is minus 32a minus 7 into 4 is 28 plus 8 into minus 2 is minus 16 plus 3b. Right? So let's do one thing. Bring 32a to the left hand side. So it is 32a is equal to 3b minus 28 and 16 together will be 44. Right? So this is one equation that we get from here. Okay, now whatever we did for x plus 2, let's do it for x minus 1 also. X plus 2 is a factor, we have done that. Now let's use x minus 1 as a factor. What will happen? We will say that for x minus 1 to be a factor again, we will take x minus 1 equal to 0 and we get a value of x equal to 1. We will put x equal to 1 in this given expression to find the remainder when it is divided by x minus 1. That remainder should be equal to 4a into 1 cube minus 7 into 1 square, right, plus 8 into 1, okay, and plus 3b. Alright. So from here, we know that x minus 1 is a factor. So in this case also, the remainder should be 0. So 0 equal to, now simplify, 1 cube is 1, so it is 4a minus 7, 8 into 1 is 8, right, now plus 3b. So from here we have 0 is equal to 4a plus 8 minus 7, that is plus 1 plus 3b. Alright, so from here we get 4a is equal to minus 1 minus 3b. Right, so these are the two equations that we have. Right, so I just repeat the concept here. What we did was, we said that if x plus 2 is a factor, that means when this expression is divided by x plus 2, the remainder should be equal to 0. Similarly, if x minus 1 is a factor, then again, when this expression is divided by x minus 1, again the remainder should be equal to 0. Right? Okay, so using these two things, we have two equations now. One equation is 32a equal to 3b minus 44, and the second equation is 4a is equal to minus 1 minus 3b. Let's do one thing. Let's simply add these two equations. So what I'll do, I'll write these two equations again and then we will add them. So this was equation number 1 and this was equation number 2. If you add them, left hand side will be 32a plus 4a, that is 36a. Right hand side will be 3b cancelled. So we have minus 1 minus 44, that is minus 45. 9 cancels 36 4 times and 45 5 times, so it is minus 5. So 4a is equal to minus 5. That means a is equal to minus 5 by 4. Right, so we have calculated the value of a here. Now let's do one thing. Let's put 4a equal to minus 5 in the second equation. The second equation was, I'll write again, it is 4a equal to minus 1 minus 3b. Right, so in place of 4a, just put minus 5. That is equal to minus 1 minus 3b. Right, 3b comes to the left hand side, so becomes plus 3b. Minus 5 goes to the right hand side, so becomes plus 5. Right, so we have 3b equal to 5 minus 1, that is 4. So b is equal to 4 by 3. So the final answer of the question is a equal to minus 5 by 4 and b equal to 4 by 3. Right. So the answer of the question, minus 5 by 4 and 4 by 3. But the basic concept was to understand that when there is a factor given, if you find the remainder, that remainder has to be equal to 0. Alright.
Okay, now we come to the last part of this chapter of this topic, that is LCM and HCF of polynomials. Right? Very simple. It is based on factorization. Let's say if I say find HCF of x square and x cube. Right? Now see, x square is equal to simply x into x. X cube is equal to x into x into x. Look at the common part. Now whatever maximum common it is, that will be the HCF. So it is x square. And what is let's say HCF and LCM also. So what is LCM in this case? In case of LCM, the common part has to be taken only once, so x square, into the remaining part everywhere, so x, so it is x cube. Now this was very simple. Let's take another example. If I say find HCF and LCM of, let's say, x square minus 5x plus 6 and x square minus 3x plus 2. Now what we need to do is, first we need to factorize. So x square minus 5x plus 6 is equal to x square minus 1 into 6 is 2 into 3, so it is 2x minus 3x plus 6, and this will give us x minus 2 into x minus 3. Right? The other one, that is x square minus 3x plus 2, you have to factorize it. So 1 into 2 is 2 and 1 plus 2 is 3. So it is x square minus 2x minus x plus 2. So this gives us x minus 2 into x minus 1. Right? Now look at this. HCF will be the total common part. Now what is common here? X minus 3 is not common, x minus 1 is not common, x minus 2, they are common. So HCF is only the common part written only once. So just x minus 2. This is the HCF of these two polynomials. So I repeat, whatever is the common thing, just take out. Only the common thing is the HCF. Right? Now what about LCM? Now LCM is that common thing taken once and everything else. So whatever remains, just take everything. So here x minus 2 is common, we have taken it once. Then x minus 3 from here. Okay? And x minus 1 from here. Right? So this is the LCM. That's it. There is nothing great about this situation. So whatever is common will be taken as HCF just once, and LCM will be the common thing only once, and everything remaining that is there will be multiplied to that. Okay. So this is what we have for LCM and HCF, and the further rule of LCM and HCF will apply to this also. If there are, let's say, two expressions E1 and E2, and their HCF is H and LCM is L, then the rule that is applicable here also is E1 into E2 is equal to L into H. Right? So this is a very important rule that is applicable for numbers as well as expressions also. Okay. Now let's take a couple of questions on LCM HCF and then we'll wind up this chapter. Alright.
Alright, now let's take up some questions for practice for LCM HCF of algebraic expressions or polynomials. Let's take up the first question. We have to find HCF and LCM of these two expressions. Let's first simplify them. The first one is equal to, actually if you see, take a common. The first step was to factorize. So first you factorize the first one. If you take out a common, it will give us a square plus 2a minus 3. Now here this can be factorized as a into. Now this 2a can be written as a square plus 1 into 3, and 3 minus 1 is 2. So it is 3a minus 3. Right? So it is a into a square plus 3a will give us a common. So it is a plus 3. Then minus 1 common. So a plus 3. Alright. So we have a into a plus 3 into a minus 1. This is the factorized form of the first expression. Now the second one, again we have a common. So we'll be getting 2a square plus 5a minus 3. Now 2 into 3 is 6. And the difference has to be 5. So it is 6 into 1. Right. So a into 2a square plus 6a minus 3. We have done the factorization earlier. Right. So from there we are doing it like this. So it is a into, now from 2a square and 6a, 2a is common and we are getting a plus 3. Then minus 1 common, again a plus 3. Right. So we have a into a plus 3 completely out and 2a minus 1. Right. Now look at these two expressions carefully and see what all things are common. Right. I hope you can see very clearly the whatever is common will be the HCF. So HCF here is equal to, now a is common in both. So it is a plus 3 is also common in both. So it is into a plus 3. So a into a plus 3 is the HCF. Right. And then LCM. What will be LCM? Now LCM is whatever is common in both will appear only once in LCM. So a is common, so it will appear only once. A plus 3 is common, so appear only once. Then whatever remaining, right, will take everything. So a minus 1 will also be a part of LCM and 2a minus 1 will also be a part of LCM. So the LCM is a into a plus 3 into a minus 1 into 2a minus 1. Whereas the HCF was just a into a plus 3. Alright, so whatever is common to both will be the HCF. In LCM, the common part appears once and whatever remains will appear as it is. Alright, so let's take up one more example on this. Now let's take up the second question, still the same thing, find HCF and LCM. First, let's factorize. Now this is slightly different. It is 4u square minus 9v square. This can be taken as 2u whole square minus 3v whole square. And then we know x square minus y square is x minus y. So 2u minus 3v into 2u plus 3v. Right? And the second one here, it will be 2u square minus 3v. So take u common. So it will be 2u minus 3v. That's it. I think you cannot go further. So very clearly, you can see the HCF is the common to both. Now the common to both is 2u minus 3v. So HCF is 2u minus 3v. That's it. Alright. And LCM will be equal to whatever is common to both appears once. So it is 2u minus 3v into whatever remains comes everything. So it is 2u plus 3v, right, from the first one and u from the second one. So this is the LCM of this situation. Alright. Let's take one more example. Now in this third question, we have m square plus 9m plus 20 and m square plus 13m plus 36. We have to find HCF and LCM. So first step, factorize. Here it is 1 into 20. 20 is 4 into 5. 4 plus 5 is 9. So it is m square plus 4m plus 5m plus 20. Right? So this gives us m common, m plus 4. And then 5 common, m plus 4. Alright. So it is m plus 4 into m plus 5. Okay. Now the second one, it is m square. So 1 into 36, that is 4 into 9, right? So it is 4 plus 9 is 13. So it is m square plus 4m plus 9m plus 36. So this gives us m common into m plus 4 plus 9 common into m plus 4. So finally we have m plus 4 into m plus 9. Alright. So HCF of these two expressions, the thing that is common, so m plus 4 is common. So HCF is m plus 4 and LCM is very clearly whatever is common should come once. So m plus 4 into m plus 5 from here and m plus 9 from here. So it is m plus 5 into m plus 9. So LCM is this whole thing. Alright. So I think this is a good sufficient example for calculation of LCM and HCF. Now let's take one peculiar example on the property of LCM and HCF. Now, this is a very important property of LCM and HCF of any two things. Now, any two things means the two things can be numbers or polynomials, right? The property will be that the product of LCM and HCF is equal to the product of numbers, right? So memorize this: product of LCM HCF has to be equal to product of numbers. Now on the basis of this, let's take up one question. It says if HCF of two polynomials is 2u plus 5v and their LCM is 3u into 2u plus 5v into 2u minus 5v, and one polynomial is given 4u square minus 25v square, then find the other polynomial. So we'll just apply this formula: LCM into HCF is equal to A into B, right? So here in place of LCM, we will put this whole expression, that is, so LCM into HCF is equal to first polynomial, polynomial 1 into polynomial 2, right? So what we will do is, in place of LCM, we will write 3u into 2u plus 5v into 2u minus 5v. This is the LCM, into the HCF. HCF here is given as 2u plus 5v. We'll put it here. 2u plus 5v should be equal to, the first polynomial is this one, 4u square minus 25v square. 4v square minus 25v square into the second polynomial. Let's call it poly 2, right? Now here what we can see is that if I simply multiply 2u plus 5v and 2u minus 5v, this will become, let's say it is 3u into 2u plus 5v into 2u minus 5v will become 2u square, that is 4u square, minus 5v square, that is 25v square, into 2u plus 5v is equal to 4u square minus 25v square into polynomial 2, right? As you can see, this whole second part is divisible. 4u square minus 25v square is completely divisible. So what we get is, second polynomial is equal to, polynomial 2 is equal to 3u into 2u plus 5v. 3u into 2u plus 5v. If you wish, you can open it and you can write it as 6u square plus 15uv. But in any case, this is the answer of this question, right? And it was based on the simple property that LCM into HCF is equal to the product of polynomials. And this is applicable for any two numbers, any two items, any two polynomials. All right.